Welcome. I'm glad to see so many people here. As I said in the intro, I'm going to talk a bit about how you get your source code from your development machine and into production with a bit of tooling I'm going to demonstrate today. My name is Asbjørn Ulsberg. I'm a core contributor to GitVersion, one of the tools I'm going to be using today. I've been, as I said, programming for 30 years as a hobby, so I really love this stuff. You can reach me on Twitter. Please do if you have any feedback or questions. And I work as a business architect in PayX, mainly focused on APIs and DevOps, trying to make that work in a fairly big organization. The toolchain we're going to be using today involves Git for source control, Cake for build automation, GitVersion for version numbering, TeamCity for continuous integration and build server, and then lastly Octopus Deploy for release management. This is what a traditional DevOps pipeline might look like. We start by planning, then we create the software, we build it, package it, release it, configure it, and then monitor, and then continue the cycle. I will not cover monitoring or planning in this talk. So we'll start by creating some software in Git with Cake. We'll use GitVersion, and we'll push the code to TeamCity, which will build it. We'll use Octopus Deploy's tooling in TeamCity to package it, and then do release and configuration with Octopus Deploy. The flowchart will look a bit like this. Develop in Git, push it to TeamCity, use Cake. Cake invokes GitVersion, which provides us with a version number. This version number stamps the package, and the package with the version number is pushed to Octopus Deploy, which will then create a release that is deployed to a staging and production environment. So let's see how this looks like in practice. We'll start by just adding something to our repository here. This is a local repository that has a remote repository which is monitored by TeamCity. Now I'm just adding this README file. And I push that, and now we can go into TeamCity to create a project based on this repository. This repository just lives locally on my machine, so it will go a bit faster, and we are that dependent on the internet, but I should need a Wi-Fi here actually. Let's try this one. Yep. We don't have any build steps yet, but oh, could not be joined. That's a problem. Minor 5. Yep. And then we'll just adjust the version control settings that was added here. We'll just remove this because it's a bit restrictive. And then we'll add a branch specification telling us to build all branches. That's useful, and then we'll adjust down the timer here just for demonstration purposes. And now if we just open the README here, we can add a little text and then we can commit it. And since we haven't built this project yet, we'll just click run because the detection won't kick in until TeamCity has detected it. So it's you can see here it's creating a build counter for our build. And what we're going to do next is add cake, but before that I just want to show GitVersion what it does. It provides our repository with a version number, and since we're now on the master branch, we do not have any pre-release information here, and you're going to see why that's useful later. But GitVersion basically just creates a version number for the given commit on the branch it resides in. As you know, in Git you can have many references pointing to the same commit, so depending on which reference, that being a tag or a branch, you have checked out, the version number may be different. And GitVersion has all this knowledge built in, so it will generate that automatically for you. What we're going to do now is introduce cake to our build. I'll just show you. It's really easy. Just copy the code here for Windows, Linux, and Mac OS. That basically just downloads a bash script. You can see it's now here in our working folder. We just need to make that executable. And we'll just add build.cake file as well. Add those. And we'll go over to TeamCity and edit our build configuration to actually run our build script. We'll do a command line. Just call it build and do a executable. And like that, our build script should start building. It won't do anything interesting yet because it's just an empty build script, but we can run it locally and just see what happens. It's going to download a NuGet. It works cross-platform, so you should be able to run this anywhere. And when NuGet is downloaded, it's again used to download cake, which will execute our build script. If just the demo gods are nice to me and the network is working, yeah. There you can see it's downloaded cake, and the build doesn't really do anything because it's empty. So let's continue with adding something to our build script. This is kind of an initial take on the build script. It's you have an argument here that we can pass on the command line to specify which task we are going to execute with cake. And we provide a default value, just called default here, and then that target is executed with this command down here. And this default task, what it does is just print hello Vilnius to the command line. So if we now run this, it has already downloaded cake, so it should go a bit faster. You can see we now have hello Vilnius on the command line. We can commit that. Yes, let's now go a bit further and oops. There we go. We have now added an instruction on the top here to install a tool. We install that from NuGet, and the package name is GitVersion command line. And what we do with that tool is invoke GitVersion, the same thing I invoked on the command line earlier, and we output the data in JSON. That JSON is being read into this GitVersion object, and we can then use that to extract the version information. You can see I use NuGet version. You can use any of the provided GitVersion variables here you want. You probably want to use the full semantic version instead. This is just, I'm used to building for NuGet with .NET, so I use the NuGet version. And if we now run this, you should see the version number printed to the console as well. You can see now we have Git version 0.1.0. And if we now continue and add another task that invokes GitVersion again, but this time with an output of build server, this task will provide TeamCity with the same version number. And we've now said that the default task should be dependent on our GitVersion task. So that's how we declare task dependencies, and it's best practice to keep your tasks as simple and small as possible so you can compose them in different ways. And now if we just commit this, and take a look at TeamCity and just provide a GitVersion with a bit of information, we need to add a parameter. What GitVersion needs to know is the branch that is being built. As I mentioned earlier, a git commit can be referenced by many different references. So we need to know which of these references is being built by TeamCity to provide the correct version number. And now that's in place, we can we should be able to push and see the build show up, and it should now start by incrementing the build counter when the build finally starts. And when exit code 1. Interesting. Okay, it failed on the network. This is not what I prayed to the demigods for. Let's try to run it again. Looks like it's working better now. It might take a while because TeamCity is now doing the same thing I did locally earlier. It's running the build script, downloading NuGet. NuGet downloads Cake, and then Cake executes our build script. And now it's done, and you can see that it's provided us with a version number here in TeamCity as well. Now let's continue with adding something to actually package some source code here, because we only created a build script so far. And we do that by adding a task called Octopack. It's dependent on GitVersion. So it will run after GitVersion is run. And then what we say is just package an index.html file as kind of our package. That's what we want to release into staging and production later. And if we look at that index HTML file, it's just a really stupid, simple HTML file saying hello Vilnius. And if we add that, we can go to TeamCity and modify our build configuration again. We can say that we now have an artifact. And what this does is give us, you just provide it with a path or a wildcard or anything that globs and ends up in a file or a list of files. And this makes it possible to use that artifact in TeamCity to create dependencies and to use that artifact in other build configurations, even other projects. So I'm not going to show that today, but it's a really useful feature to be aware of and to use if you want to be efficient in TeamCity. And you can then create parallel build chains and do stuff in parallel to increase the speed of your builds, to break it up into smaller parts and stuff like that if you want to do that. So now that TeamCity picks up that change and starts the build, we see that the previous build had no artifacts, and the next build is going to have, if everything works, an artifact exposed. We can also just run the build locally and see that we end up with an artifact here as well. Network is slow. Yes, it's been on 45 seconds now. What we can do is, of course, go into the look here. Yes, it's failing on the network. I was promised this was not going to happen. Let's just try to run the build again. Is the network here? Yes. There we go. Now we have an artifact. And this can be expanded, and you can download individual files from the artifact, or you can download the artifact itself just to see its content. It could be useful for debugging. Now we're going to expand our build script, and what we'll do now is we'll add an octo push step to our build. What it will do is pick up our NuGet package, and it will push it to Octopus Deploy. From there we can continue the build pipeline in Octopus Deploy, as I will show you shortly. So if we and I also forgot to mention, we added a so-called meta task here. It doesn't do anything itself, it's just a task we create to differentiate the build given the target that is sent in. So the default task is still dependent on octopack. So when you run this locally or without a target argument, Octopack is what's going to be run. So we won't push anything to Octopus Deploy from your local computer. We want to kind of preserve that for TeamCity. So this is not a security feature, it's just so you don't do anything stupid by default on your local machine. Because we usually don't want every developer build in Octopus Deploy. So what we need to do then, just need to commit it. And we need to edit our build configuration again and the build step. And now we need to provide it with our target. So with target TeamCity, it should run the correct task when we now push. And what's going to happen then is all the previous build steps we've seen is going to be executed, GitVersion, Octopack, and now Octopush as well, which will push this versioned package, the version number provided by GitVersion, up to Octopus Deploy. And let's hope the network doesn't fail again, so this will go quickly. And there we go. So now, if we move on to Octopus Deploy, we should have that package available. So let's add a project. Let's add a step to our project. We're going to deploy to Internet Information Server. There will be some specifics for Internet Information Server here, so if you're not familiar with that web server, just please ignore it. But what's not IIS specific here is what role you want to execute this build step on, or what you want to deploy it to. So you can define roles for all your servers. So you can have a backend and a front end, or a web and an application server, and so on. They are just custom labels you use to add an abstraction over your deploy targets or your servers. So web servers is where this is going, and we need to choose which package. And as you can see, we've now have the demo package available. And the name of the website is going to be a variable. And we are going to create that variable later. The same with the application pool, and this is kind of the very IIS specific stuff. And then the bindings might seem a bit more familiar. We're also going to use a variable for the port number. So here we have two variables, port and environment. We're going to create those soon. And we need to have anonymous authentication. And we need to add variable substitution to this task, because we are later going to use those variables in our HTML file. So if we now go here, we don't have a release because we haven't created one, but we have a package we could create a release manually from. But instead I'm going to create a new task called Octo Release, and what it's going to do is create the release from the package we have pushed. And that's going to be provided here soon. So now TeamCity is building our new package, and it should both now upload the package to Octopus Deploy and initiate a release. And if we now look here, we have a release, and we can now deploy that to our staging environment. if everything works. No, it doesn't, because we didn't create our variables. Sorry. We need to create a variable environment, and it's going to be production for the production environment, not surprisingly, and then staging for the staging environment. And we need the port as well. 81 for staging and 82 for production. Save that, and we can go back here and we can retry this deploy. Oh, sorry. We could update the variables here, or we can just create a new release instead. You can see that's quite easy. Based on the package we just had, we just create a new release. It's really simple and quick. And what I showed here is a neat feature of Octopus Deploy, actually, that the package or the release is immutable. So if we now deploy this, and as you can see, it told us we changed something since this release was created. So in order to get those changes into our package, we need to recreate it. So now we deploy that to staging. We should be able to see that page here. So there it is. It's not much of a demo yet, but if we go back to here, it should now be in production as well. You can see it's two tabs pointing at different websites on my computer. And the next thing we're going to do is, I don't want to do this deployment stuff manually all the time, at least not for the staging environment. So what we'll do now is add an Octo deploy step, and we'll give this a criteria that says that only the master branch should be, or builds from the master branch should end up in Octopus Deploy staging environment. We do this by checking just the GitVersion pre-release tag. If it's empty, then we'll allow it and continue on with releasing this thing to the staging environment. We'll also do something more here. We'll show how GitVersion creates version numbers for different branches. And push that. And now TeamCity is going to build this, but it won't execute the Octo deploy because we've pushed this from the develop branch. So when TeamCity pushes starts. Okay, thank you for that. We gotta execute one again. I'm sorry about that. Let's just ignore that. Let's continue to actually make a stable build instead. And now we can tag it. What I could show, actually, if we go to is how GitVersion now creates a different version number, including this pre-release tag. So you can see here now the pre-release information is filled out. But if we go back to master and now add a tag, we push that tag, and we push the source being referenced by the tag as well. If the network now works, hopefully TeamCity should create a new build with a new version number for our master as well. And then, since we have a master build now, it should also do the release to staging. So let's just cross our fingers that the network is working now. It's been working sort of 50% of our builds. So since the last one was red, this one should turn green. Fingers crossed. It looks like it might be working. So if we just keep an eye here on what's happening in our demo project. Oh, come on, please. This is the... No, okay. I'll just continue with step number 7, which is just to actually add some there we go. Add something interesting to our HTML file to use these variables we defined in Octopus Deploy. You can see we use the environment as a class name, and we also use that in the body to output it, so we kind of prove that this is indeed working. Let's see if this... Oh, it's successful. Cool. So now you can see that the package was automatically published to staging. And if we now commit this, add a new tag, let's hope we get another successful build. It should now do the same. It should package the index file, it should push it to Octopus Deploy, and initiate a release for the staging environment. And in the release, it's also going to merge the variables we defined into the index document, so we can see that we can actually affect the package we release and deploy. So there we have a successful build. Now if we just look here, it's started deploying to staging, and we can continue to deploy this to production as well. And if we now look at the document here in the staging environment, we can see that it has our version number available in the HTML, and it's also merged in the value from the environment. And the same thing should now be in production. So now you can see the background color there is different because the styling was different. So that's how you can use all these tools to simplify a build pipeline and to integrate it all together. And with that, I'm done.